rooms problem, though, is something I was just like, you know what, to hell with this. You can either, make your own, relay system that does all that crap and can route things to a room and then look up the contents of the room and then route those to all the people. Or you can just, like, hook up an XMPP server, like eJabbered or something, and just say, to hell with this, somebody solved this in the 80s. And if I have to do anything else, please give me a larger budget. Alright, so let's pop up in this blueprint and add in the blur radius value. You're on the 1970s nickel-plated toaster. You might want to upgrade to the 1980s tin-plated toaster. Or maybe like a 1990s Black & Decker toaster model, which might even have some stainless steel in it. That probably would give you better reception. We're going to have an end of life on that nickel-plated toaster shortly. And don't try to use the 1960s lead-plated toaster either. That will not work. So this is going to be our magnitude fill radius. We're going to put that in speed. This will be an int 32. This is how far apart we look for filling in magnitudes. Don't worry about this variable. Alright, so we'll compile and save that. Why can't we compile it? Thanks. 16 should go from maybe like 2 to 32. It'd just be like this. There you go. Snag this, throw it in there. We'll be good to go. Lead paint, that's for sure. Don't worry, it's got dual SLI George Foreman's. Damn, dude. That's like a 1-2 punch of network communication right there. I can only talk to other people through grill markings. Alright, so I think we've got pretty much all the stuff saved, nicely done there, and set up. So what I want to do is I'd like to... Like, we've got the actual data, that is saved. We've got the texture, that's there. Yeah. I'm basically just thinking about what else I need to do for this in order to do it. So I can clean up the code. So, but I think I need to change the material for this thing so I can actually like see stuff. I'd like to be able to see the direction of the flow field and not just the flow field itself. So let's have a constant in here for multiplying. So we're going to have promote parameter on this. I want to be able to switch from the alpha channel to the RGB channel. So I'm going to say debug alpha. So we'll multiply this by debug alpha and add it together with this thing. And we're going to multiply this by debug alpha. And is there like a 1 minus? Yeah, okay, cool. I'll actually start using some of these nodes. because I should be using them. This is emissive. And this needs to be hooked up differently. So this one's going to go here. This value needs to actually be multiplied out here by the test weight to go into the emissive channel. Alright, debug alpha should start off with a default value of 0. Alright, that's fine. Test weight -1, so why don't we just do our 1 minus in here. Cool. Alright, Karakan, have a good night. I think it was pretty funny. One of the memories I have working at Amazon, I was going over, like, me and one of the other guys had, we were giving a presentation on how to build game server systems to, like, all the dudes at Lumberyard. That's pretty funny because we're talking about how we needed push messages, push message notifications to all of our users. Because we need a way to push messages out there. So like if you're waiting for matchmaking or something, like the architecture could be you enter matchmaking and then you keep polling to see like is the match found yet? Because normally in your server architecture you've got like your client machine down here, and then you've got your client is connected through like a load balancer to a specific machine, which is kind of like processing your game. And then like if you have matchmaking, you might actually have like a matchmaking service, which this thing calls back to. So the question would be like, this kind of your kind of your thing. Like you have your gateway load balancer here, you've got your actual like your game service, and then you might have like your matchmaking service over here, and like you might even have like your game server. This might be your sort of architecture. So the question would be like, if you want to join a match or something, like if this is Rocket League or something else, right? Like this is your client, this is like your PlayStation 4, and then you got your load balancer, which is what you connect to, and your load balancer is going to do stuff, like denial of service protection and all that sort of crap. And you might even have, your load balancer might be combined with an authentication system or some other shit. We'll ignore that. We'll say you're logged in and got the right credentials. So like the load balancer will like pass on, you have like a message. Matchmaking is random, so split by region. You might have like your load balancer go back to your game service, which actually says, oh, this is a matchmaking entrance request. Okay, well, cool, you're on PlayStation, so we're gonna have to talk to the matchmaking service, and we have a matchmaking service that matches everything. And we just say like enter matchmaking for PlayStation for randoms or something. And this matchmaker is going to be crunching away, trying to find all the people you want. And then once it actually gets the answer, it's going to have, like, how does this happen? How does the matchmaker come back and say, hey, client, man, you're ready to go? So, you could, like, poll, and, like, every 2 seconds, the client could ask, like, dude, where's my match? And, your polling speed would also be your minimum speed for your matchmaking, right? Like, yeah, that's one thing they do. They also, usually your load balancers will help it so you can, route traffic to different servers and take these game services up and down without downtime. But yeah, that's one piece of the pie. Let the pulling speed be dynamic. Yeah, so you pull, and then you have clients here. Nobody ever writes any malicious clients for games. That just doesn't happen, right? So these things are pulling and slamming more bits into your front end and making more messages and more queries, which all go back to your matchmaker, which is trying to find matches. And if people, it'd be like you got some guy behind a counter and he's like trying to match you with like a date or something like that, and then in front of him are like 100 people just like yelling at him and like, are you done yet? Are you done yet? Jesus fucking Christ, man, it's Friday night and my hormones are raging. Please, for the love of God, give me a goddamn match already. And this guy's like, Jesus, okay, here you go. And then the person comes back, he's like, no, this is my mom, Jesus. And then you're like, and then then he needs to find another match. It's like, God, fuck, these people are animals. So this matchmaker needs a system to send messages back. So we're trying to explain, like, you need some sort of, the client needs to be connected to something here. Like, we need some sort of way for this matchmaker to send a message to, a post office sort of thing, which can send a message to the load balancer that this guy is connected to in order to forward the message or something like that, right? Yeah, rest in peace. So we're saying, like, well, you need something like this. We called it the relay service message, where you could address a message to a user and it would get to the user, and the speed of the relay service would be, speed of light, be 1 millisecond or less plus the speed of light to the player. So like if you joined a match, you would immediately get a response when the match was created. So everybody goes in the match at the same time. Real cool. It's not like a 1 second lag or some shit. Because basically, this matchmaking service also needs to, be able to call this game server. And how the hell does this thing call the game server? Because it needs to go ask the game server if it's actually ready to go. Otherwise, you might get a match, and then the game server, like, crashed in the meantime. And so you get, like, your matchmaking thing going on there, and then, boom, the game server's offline. So you got to re-enter matchmaking. So all that sort of crap. So, like, as we're going over all the complex steps, and it's like, well, it's just the same thing. We call the relay service and we say game server 1, and then this thing can go talk to the game server. The game server can say, yes, I'm ready to go, and I can accept all those people, and then this will just come back over here. And so the game servers need to be logged in and use the same technology as like the clients logging in, because maybe a game server is on a client machine. And then, after the match is made, it can then call back over this guy, call this guy, and then the client can actually connect to the goddamn game server and then own everybody inside of their game. Or maybe they suck and they immediately disconnect to be like, that match sucks. Don't worry, guys, that's just the emergency broadcast system activating on my phone. Good job, phone. Some child has been abducted. This is a horrible tragedy. But back to game servers. Anyway, so we explained all that. Yeah, it sounds great. In reality, the client might have money. Yeah. I don't own a BMW. Yeah, that's some of the funny things. So one of their solution was, okay, well, we'll just have an SQS queue for everything. So these clients connect to, we would use SQS, which, if you're not familiar, this is Amazon's simple queue service for every client. So I'm like, okay, cool. So we're gonna have, how many clients are you gonna have? If you have 100,000 people online, let's say we're FIFA here and we have 400,000 people online worldwide. What are you going to do? And they're like, oh, well, we'll just have one queue per person. It's like, okay, cool. How do you get a response from that user? Oh, well, you just address, we have also one queue per service. It's like, okay, well, that's not a big deal. The services on the back end can have their own queues. How you assign those might be non-trivial, but let's just say you do. And then you go look up like the service limits for SQS, and it's like you can't have more than 100,000, otherwise stuff doesn't work. Regardless, SQS works with polling. So its pricing model is like, a cent per every 10,000 messages or 10,000 requests or something like that. And you might think, oh, that's not a big deal. It's actually a gigantic deal if 100,000 people are hitting your servers every second. Anyway, basically, they came up with an architecture that was complete horseshit, and they're still having problems with it to this day. They basically are just pouring money into just the fucking black hole of all this stuff, and it's like all you needed was a goddamn relay service cluster and to actually go write it. And they're like, no, we can use all this generic crap off the shelf. And I'm like, you know what? I don't think things that are made for web applications are gonna work for all games, dude. And yeah, let's just say we're just gonna throw money on the floor. Everybody, God, it's funny. It's just funny because I came from like a startup down in San Diego where everything was about, like, we need to price things properly and be frugal. And you go to Amazon, who's always like, we're gonna be frugal, and then like they just throw money into a hole. And you're just like, Jesus Christ. I don't think you know what that word means. Anyway, back to actually doing things. So our test weight is going to be in here. That's going to be multiplied out. We need the debug alpha variable to be set, and the debug alpha needs to be a little checkbox here for me. So we're going to go into our test water update shader parameters function. I'm going to close all the tabs here. And I'm going to want a Boolean value here for debugging. So we'll duplicate this one, and it'll be like debug alpha. So this will be toggle viewing the alpha channel for debugging purposes. Alright, so it's going to be set scalar parameter value. I don't know, if people are interested in server architecture stuff and all that, I could go over that crap for days. I could draw an entire like service stack diagram from scratch and like just from memory, start to finish. I've built so damn many of them that Alright, so we got the alpha channel. We're going to want to call set scalar parameter value. And we're either going to set it to 0 or 1. This will be debug alpha var. This will be a float. Alright, so do a branch. So if debug alpha, otherwise blah, get this, shove it in here. It's going to be called debug alpha. That gets slammed into there. If this is true, then we do a set and a set, and then we move on. Alright, so we got this set. This will set to 1. This will set to not 1. Alright, so if we compile and save that, then we get an error. And this is getting all pissed off because we do not have a material instance. Well then let's get one. Alright, cool. So debug alpha will allow us to switch back and forth between our flow field direction vectors and our stuff here. So we can test our flow field. This is our particle flow field. Let's call this test flow particles. Compile that. So this will be your flow particles. The alpha is 0 here. Test the height map. The alpha map is the distance to the bottom, so we can see our distances there. And then we can check our distance map, which is our red channel there. So we're good to go for, I think, viewing all of our various debugging things. For web and engine access simultaneously? Yeah, like... Yeah, we did all that back with like Dragon Age Legends. Like, it's pretty simple. Like, if you've got like your web client, because we had kind of our because we had for Dragon Age Legends, we had the mobile site as well. So kind of how the architecture looked like is we got our it kind of looks something like this, where we've got like the mobile clients would like connect to a separate endpoint entirely. So you've got like architecture that looks all over the place, like stuff like this. You know, it's just simple like that. So like you could send all sorts of messages everywhere. So like your web client, you could like click on the little dude and send him to work, and that would send a message across the load balancer to your Dragon Age Legends server, which could send a message if you were connected to the mobile client saying like, oh, well that thing, a thing happened, and then this guy can like reload the state if he needs to, or even respond to a specific message. So there's all sorts of architecture stuff that we did. But yeah, we had that back in 2009 with Flash client and mobile client, where you'd like assign some people to do stuff. And that way, that's because like we built the. It was pretty funny. We built the whole mobile server when I was like just in my free time. I built it in one day after over thanks. It wasn't one day. It was like over Thanksgiving holiday. I just like banged out this server for this guy and hooked it into Dragon Age Legends and all that, so he could actually access everything. And then the guy spent the next X number of months building the mobile application itself. But it was just because he could just tie into the existing framework and make calls onto the back end nicely, and it was all good to go. All right, so we have this. We have our information. So that's our magnitudes. That's our directions. We can look it up. I guess we should clean up the code now a little bit, because I think that's our flow field being finished. So let's try to make this all not awful. I mean, it's awful. Let's just make it a little bit less awful. Alright, so... Alright, so flow pixels. This is our tiered average tiles. level tile, blah blah, post process, everything there. So this is map utils. Should we throw all this stuff into like a separate file? Create static flow field. I mean, it's... I don't think so. I think we'll be okay. Right, you calculated flow field. Set up a map, discover flow objects. Path. That's looking okay. Guess we can remove some of these debugging things that we've got going on. So we got our flow objects. Okay, that's fine. That's fine. Blurring pixels. Alright. These tiered average holder things, I think we're gonna shove those at the bottom of the file. Alright, cool. So we'll get this rolling along. So this will be called to initialize the average holder data. This will be called to get the tile for a position. Call to rate a pixel to the multi-tiered average holder. So we call to post process our averaged data. Alright, so we'll call to grab that. So let's see, blurring pixels, paths. We have the water flow object, we have the path, we have the flow path. Flow path map is still going on here. Spawning particles, trying to spawn particles, doing all sorts of stuff. God, we have so much stuff that went together to make this thing. You're talking to fellow computer scientists. I don't know. I would avoid those people. They can be kind of strange. Yeah, one of the things that I was not expecting becoming a server engineer was just how involved with the business side of things you have to be aware. Because a lot of stuff like gameplay programming, AI programming, etc., like it's good to be aware of how, the business works and, where money is coming in, but it's not the same as when you're there. Like, I didn't expect it, but like the decisions you make on a daily basis for server engineering directly affect how much money the project has to spend on, like, a weekly basis to keep everything running. And you don't really do that as a gameplay engineer. You don't like sit down and be like, okay, well, if we have the jump button mapped to the B button on the Xbox controller, then it's going to cost another $20,000 a month to run our game servers. Like, that's not really something that happens. So, as a lot of game programmers, etc., that I would work with would never have any concept of how much money anything costs or any of that. But like the server engineers always had to keep that in mind. Like, I can solve this problem right now by throwing $500,000 at it, or I could spend 2 weeks on it. What would you rather have me do, Mr. Producer? Those are questions that actually do come up all the time when you're doing server engineering, which gives you a much better perspective on how everything works as a business. It's interesting. For better or worse, everything starts to become dollar signs for you after a while. You don't see databases. You don't see servers. All you see are, that's going to be $500 a month right there. That's going to be 2 cents per gigabyte. Alright, so I think we've got everything kind of cleaned up a little bit here. So what we should do now is run through a few cases with our water again and see if our flow and magnitude fields look anywhere near decent. So let's see what happens if we throw a rock in our flow field over here. Hello, NiloFE. I am working in C++ and Blueprints, and they both have their purpose. Like, C++ is really good for building the more complex systems, and Blueprints are good for stuff that can be quickly iterated on. Not that you can't make a game entirely in Blueprints, I just wouldn't recommend it. Alright, so we'll check this thing out and generate our flow field, and then we'll see what it looks like. So that's our flow, and this is our direction. So if we look at our particles, it looks like that. Our distance map, well, our distance map is gonna look like that. Alright, so does this look correct? I mean, this direction stuff, this is going to be going straight south, and it looks like then it's going to be going straight up. So if we were something here, we get... I mean, it looks pretty close to what we'd want, yeah. And the magnitude, things are going to be moving quick around it and all that. That looks... I am happy with this. So let's see what we can do to kind of screw with this a little bit. Let's make sure it does what we want. Let me do something like that. Trying to accept blueprints into your life. Yeah, I was using Unity before I switched over to Unreal 4. We're using Unreal 4 as opposed to Unity mainly because of the lighting and shadows and everything else. And material editing stuff. That's pretty cool. So we're right now working on our water. Like I'm trying to create static water flow field maps and stuff like this, so I can actually have some kind of dynamic effects in the game with water that's actually built on like real accurate or quote unquote accurate information. And this is taking a while to compute. Well, we'll see. There it goes. Alright, so that's our magnitude map for how fast stuff's going to be flowing. These are the directions for everything. I'd really have to just look at what in the hell that does, because some of these negative values are actually from like 0 to 127, and then positive values are like from 128 to 255. Oh yeah, God. That's one of the things that, for actually learning stuff, nothing beats actually sitting down and coding it and getting it working. Like a YouTube tutorial video or something else like that. Like, you can watch those all day. You could watch them forever, and to be honest, I think you never get anything out of them. Because you actually have to sit down and do stuff to really understand it, at least in my opinion. Because it's one of those things, you watch the tutorial and you're like, oh, I understand this, and then you try to implement it and just nothing works, or it doesn't work in this version or anything else, and you don't really understand what you're doing. And I don't know, I would disagree with Google. Google is a great resource for figuring stuff out. And I have found that books they were helpful to like beginning and like programming stuff in college, but after that, books and white papers turned into just like, yeah, that's what we did last year or 2 years ago. That's old. It's not good anymore. So books are good for learning stuff that's old information that you may not know yet. But man, I haven't sat down and actually read any programming books in forever, just because they're not useful. It's like went to GDC back like 2 years ago. Well, 3 years ago was the last time I went. And it was just like every talk I went to, I was just like, yeah, I already know that. God, like, this is mind-blowing to some people, I guess, but it was like, okay, if you have instance servers, make sure you can actually restart them. It's like, well, yeah, Jesus Christ, dude. Yeah, one of the statistics that I would like to see is how many people at like GDC or any of these talks are going up there horribly hungover to give their talk. God, this is gonna take forever. Alright, so let's generate our flow field now. Alright, so those are our directions. We've got those two. Our magnitude is like this, which is looking fairly good, yeah. That's going to be our direction, so our direction is going to be around there. And it's our distance. our particles look like this. So they're flowing over and through that. Alright, that looks like it's working pretty well. Let's set up a little bit of an obstacle course to see what this thing's going to do when we give it some more complex choices. What's it going to choose here? Why is George Bull? What's going on? Yeah, that was one of the things. Like, I signed up for the advanced programming class freshman year in college because, you know, I'm a programmer. I know how to program, and it was like I didn't know how to program. But I had been in honors classes all through high school, so I'm like, well, I'm an honors student. Of course, I should be in advanced class. I'm a smart person. And I showed up, and the exam was not an exam. The professor just went around and talked to you for like a couple minutes. It was like, all right, do you know what a function is? Do you know what a variable is? And I was just like, no, and no. He's like, why do you want to be in the advanced class? I'm like, because I should be in the advanced class. He's like, all right, cool, welcome aboard. And that's how I got into the advanced programming class in college. It was a horrible accident. All right, so let's see. We want the actual particles here are going to look like that. All right, so it's just going to go straight over. That's fine. That's not a problem. We have to actually like drop some stuff into the water and watch it flow around. I think that's going to be what we're going to have to do to verify all this information. So I guess the next thing we need to do is figure out all that crap. So tasks. Going to make data available in Blueprint and create a floating object and actually observe their motion in various circumstances. Alright. It's going to be verify flow field data. So the other thing I'm going to do here is I'm going to test out a little bit more than just this stuff. What I'd like to do here is actually create like a little area kind of like this. And make sure that it works properly. You're having fun tinkering with Blender and Photoshop? Yeah. Tinker away. So let's construct our static flow field, construct our height map, all that sort of stuff. And we'll take and generate our flow field for this piece of object, this piece of work here. See how it goes. Well, we have, I'm not seeing the, oh, interesting. Alright, so flow particles look like that on this thing. Cool. Let's see if I can take this so it's not visible. Where is the visibility for this thing? I'm not sure we actually want this. I guess we need a direction on this variable thing. We're supposed to have an actual direction arrow on it. Let's open up our waterfall blueprint here and take a look at our components. And we should have a direction. I don't see the direction arrow though. I should be seeing that. Where's the direction arrow? These things should have a direction arrow. Like that. Should be a little orange direction arrow. So what I want is not a radial input. I don't want a radial input for this thing. This should be non-radial. Oh no, it should be radial, but okay, here we go. I screwed up this water object. Alright, let's set the size of the arrow to something reasonable. So we'll set it to something like, you know, get actor transform. Let's get the scales. Let's just take the, I guess the max. Of the absolute values of this thing. And let's do a divide. So we'll do set the arrow size to 50 divided by the scale. So this object will get smaller relatively so that the scaling doesn't get all screwed up. Because I wasn't seeing the arrow stuff actually work properly with scaling its size. So yeah, it should be 50 divided by, let's actually multiply this thing by 3, whatever. Alright, cool. Have a good one. Alright, let's see. Got these things. We want these arrows. This arrow should go 90? Yeah, it should go like this. So let's go ahead and construct the static flow field, tick the texture. Generate. And then we can take a look at what this actually looks like. Yeah, so that's looking pretty good. Like, I'm not seeing the garbage that I was seeing earlier where it was getting repelled and doing other weird crap with the radial output. So what we really want to do is we want to like spawn an object here, have it fall down here, and then have it like, you know, flow around and out. Like that's kind of what I want to look at building. To make sure that the flow field actually works properly, and then we'll like spawn a whole bunch of little things that fall in and start doing their jobs. So is collision on? Yeah, we are terrain collision. Cool, excellent. So that means things will like fall onto it. Anyway, I will be right back. And then I'll start working on making it so we can have stuff float around in this water. And I'll also start cooking some food. Looks like we actually got the first mock-up t-shirt here for this thing, for the game. Which, well, we'll see how it looks. At least this color looks like it works properly. The detail on them is really good. Like, we got these off Amazon merch, so I'm looking at like the actual details on the actual shirt, and you can see it's actually very detailed. Doesn't have a whole bunch of crappy pixelation.